What's going on, guys? Today we're going to learn how to implement the k-means clustering algorithm from scratch with Python. So what does k-means do? K-means is a clustering algorithm that is going to learn how to group data when it's unlabeled. So in this case, we only have raw data, and the algorithm attempts to group the data based on its features into which points might be most similar to most other points. Okay? So I'm going to go ahead and play this visual here so you guys can get an idea of how this works. So again, we have these initial 4 points that you can see in green there on the screen, and then for each other data point it is trying to find what the closest which of those green points it's closest to. Then once we assign each data point to a green point, it goes ahead and it finds the average, and that'll be the new location for the green point, and it continues in that loop until none of the data points are assigned to new clusters. And in that point we have our completion of the algorithm, where we have our raw data that has then been grouped into these individual groups. Okay, we can then use those groups as labels for that raw data and can proceed to do whatever else we might want to do with that, such as running it through other algorithms. Okay, so let's go ahead and get started implementing this from scratch here. So again, I'll show you guys what we're going to finish up here, what we're going to have when we're done. And again, this is what it's going to pop out to be like. So again, we have these large circles here, which are going to be the centroids. In this case, that's the we have a k number of centroids. So that's what k stands for. We define, like, say 5, 6, any arbitrary number, a number of centroids, and those are going to be the number of clusters that the algorithm attempts to break up the data into. So again, this is what we have here. This is just randomly generated data, which we have then assigned or created into groups using k-means. Okay, so let's go ahead here and start building this from scratch. So let's go ahead and create a file called kmeans.py, and in there we're going to go ahead and import the initial libraries that we're going to need. So first off here, we need numpy, so we're going to import numpy as np. We're going to import operator. This is going to be used for sorting our dictionary once we've established our points, and we're going to be able to establish the other locations as well. Next up here, we're going to import matplotlib.pyplot as PLT, and we're also going to import matplotlib. We're going to import, import matplotlib.cm as cm, and matplotlib.cm is for mapping our points to clusters. Pyplot is for being able to visualize our k-means algorithm after we're finished. Operator is for sorting of some of our dictionaries that we're going to use in order to establish the closest points for each centroid or for each cluster. And then we have numpy, of course, the scientific computing library, for being able to do this all efficiently. So now that we've got that here, first thing we're going to do is define a template for each centroid. Okay, so we're going to start off here and have a class centroid, and when this class is initialized, so when we create each instance of this template, we want it to have a few different things here. So we're going to have self, of course, and then POS, which is going to stand for position. So now we're going to have self.pos equals POS, and this is going to be how you're going to keep track of the location of the centroid in the space that the data points are in. Next up here we have self.points. Now this is just going to be an empty array. We are going to assign each point to this array for each centroid as we're moving it around. Now we have self.previousPoints, and that's going to be another empty array. We are going to use this self.previousPoints array to determine when the algorithm is finished and that none of the points have changed clusters on the previous iteration, right? As we move the points around. And finally here we have self.color, which is going to be none for now, but we are going to assign a color to the centroid based on the color map from matplotlib. So next up here, we're going to go ahead and start with our actual k-means class here for the algorithm itself. So we have class k-means. Now in here we are going to go ahead and we are going to create, again, self, and then we have a number of centroids. Now this is going to be the number of clusters that we are trying to establish out of our raw data, and these centroids can be any number of clusters, obviously minus, or we can say if you have an x number of data points, the number of clusters can be anything x minus 1 down to 1. So we've got that here. Now we're going to say self.endCentroids equals n centroids, so we can keep track of the number of clusters that we want to establish here. And then we're going to have self.centroids, and that's just going to be an empty array that we are going to later assign each, or that we're later going to fill with centroid objects. So we're going to go ahead and initialize those right now. So now we're going to say, let's generate initial centroids. So we're going to say and then the underscore there is just symbolizing almost a placeholder. So in this case, since we're just doing a loop up to a given number, that is the number of centroids, and we're not going to do anything with the specific index in that loop, then we want to go ahead and just put a placeholder there. So for placeholder in range n centroids. So for the number of centroids that we want to establish here, then we want to say self.centroids, and we want to append the centroid. So we're going to use our class that we created above for the centroid, and we are going to add that to our centroids array in our k-means class, and we are going to say, and our position is going to be a random position. So because of that, let's go up here and let's create a lambda function that is going to be able to give us a random coordinate between 1 and 100, we'll say. So we're just going to assign this to a variable called r. So we're going to say r equals lambda, and then we're just going to say np.random.rand int, and then we're going to say in range 1 and 100. So we're going to be able to call that r variable as a function, and that'll give us a random number back. So let's go ahead now and do this. We're going to say centroids.append, and then we're going to say let's append an array. So we're going to say numpy.array, and in that array we want to have these random numbers. So we're going to say r and r. Okay, so that will go ahead here and append a number of centroids. So that will establish the number of centroids and initialize them with random positions in our overall grand picture here. So let's go ahead here and continue. So now we're going to go ahead and assign a color to each of these centroids. So we've initialized them with a random position. Now let's give them a color. So assign a color to each centroid. Alright, so now we're going to say colors equals cm.rainbow and np.linspace 0, 1 length, and we're going to I'll explain this in just a second here. Self.centroids. Okay, so what this is doing here is we are basically saying let's create a number of colors and a unique color for each of these centroids that we are doing here, and we are using this using the color map from the matplotlib library. Now we're going to go ahead here and say for IC in enumerate self.centroids. So what this is doing here is we're saying for the index of the given centroid and for the actual centroid itself in the array, then we want to go ahead here and say that centroid's color is going to be colors at that index. So again, colors is going to be an array of unique colors, and we're going to go ahead and say let's iterate over our centroids, and let's assign each of those centroids color to be one of those unique colors based on the index of the centroid itself. So that's just going to give us unique colors for each centroid, so that when we want to visualize that later on, we'll be able to do so easily. Okay, so now that we've got this here, let's go ahead and just save this. We'll make sure that everything is working here properly. Alright, so we have no errors so far. That's good. So let's go ahead here and create some sample data now. So in our case, we are actually just going to be creating random sample data that has an x and a y coordinate, and then we're going to be fitting the groups out of those sample data. Now you can imagine that any data you want to use, you could feed in with that. They may have longer feature vectors than, say, just an x and a y in our case. That'll be the features for each of our data points, but you can imagine it could have 10, 15 different features, and in this case we're in a much more complex, higher dimensional space, but we're essentially doing the same exact thing, which is establishing for each point what's its closest centroid, and then let's move each centroid towards the average of its closest points. Okay, so now we're going to go ahead here and create this sample data. So we have our sample data here and a self, and then we're going to have samples that we're initially going to set to 50. This will be just for the number of samples that we want to create out of that sample data. So let me move this down here. Let me zoom in for you guys a little bit as well. Okay, so now we've got our sample data. So let's go ahead here and generate the sample data, and now we're just going to say we're going to define a variable called self.x, and that's just going to be an array of random xy coordinates that are going to be our data points. So we're going to say so we're going to use a list comprehension. So we're going to create a list of lists here, and that list of lists is going to contain the data points with those x and y coordinates. So we're going to say two random numbers representing the x and y coordinates for again placeholder and range for number of samples. All right, so that's going to create our sample data here. In this case, it's going to create 50 samples for us. So now we're going to go ahead here and create our we're going to create another couple functions, and these are going to be functions to assign each centroid and to update the centroid location. So assign each point to its respective centroid, and then update the location of each centroid based on what points are assigned or what points are assigned to it. So we're going to say def assign centroid, and that's going to be again self, and it's going to take x as the x as another parameter, and that parameter is just going to be the centroid itself. So we're just going to say this is going to return the centroid closest to a point. Oh, so that's my mistake there. So in this case, that x is going to be a data point, and then we call this function with a data point, and it returns the centroid that is closest to that data point. So we want to say distances. Let's create a dictionary here. And then we're going to say for each centroid in our centroids array that we initialized when we create this initial, when we start this algorithm, and we're going to say distances centroid. So we're going to create a key in the dictionary that is going to be each centroid, and then we're going to say the distance is going to be the Euclidean distance, which we can which is basically the distance between 2 points in the space, and we're going to say the Euclidean distance, which is we can use numpy.linalg.norm, which will give us that, and we're going to put centroid.pos and then minus x. Okay, so that will give us the distance between these points, the data point x and the centroid. So that'll go ahead and for each centroid, let's establish how far it is from the point, and then we're going to go ahead here and we're going to say closest is going to be the minimum distance. So the centroid that has the smallest distance from the point is the centroid that we want to assign that point to. So closest equals min, then we're going to say distances.items. And then we're going to go ahead and use a key, which is going to be basically we can a way to establish the minimum value here, again because we want to not use the key itself, but we want to find the minimum by the value in the dictionary. So this is a little bit has to do with just dictionary sorting here. So we're going to say key equals operator dot item getter 1, and then we want to take the final value that is our minimum. So that will be our closest point, or our closest centroid to that point, and then we want to go ahead and just return closest. Okay, so let's go ahead and just call all these functions to make sure that we don't have any errors at this point. So we'll say km equals k means, and we'll just stick with our traditional number of centroids here, and let's just make sure everything works out here. Looks good, looks good. We'll call that sample data function, and we can't, yes, so we'll say km.sample data, and then we want to assign our centroids here. So let's pick a random point here. So km km.x, and we'll take the first point, so km.x, and we're going to call that assign centroid function on that, just to test that out. So assign centroid, taking that first sample out of our sample data to use for that. Oh, let's see here, range and range samples, let's check that out there, 30. So up to x equals that for boom and range, in range. Try again here. Oops. Okay, operator is not defined. Let's go ahead and define that real quick. Operator. Okay, so everything checked out there. That is good. So we have no errors besides those first few that we fixed right there. All right, so now that we've got that here, let's go ahead and create a function that will actually update each centroid. So now that we can go ahead and find the, we can assign each point to its respective centroid, now we want to be able to update the centroids themselves based on what points were assigned to them to come to that average, okay? So that is the k-mean. So again, k is the centroids, means is the average, and then we go ahead and we do everything as was before. So we have def, and let's go ahead and create our update centroids function with, again, self, and we're going to give it a parameter called reset that is going to be true initially. Now this is just going to help us later on for cleaning up our data before we want to plot it. Okay, so we'll get to that in just a second here. And again, this is going to update the centroid position based on the mean of assigned points. Okay, so now let's go ahead here and we'll say for centroid in self.centroids. So again, we're iterating over all of our centroids here. We want to go ahead and assign the previous points to the actual points that are currently assigned so we can later compare to see if there were any changes and decide if the algorithm should come to an end. Then we want to go ahead here and say our x coordinates are going to be x. We're going to again use a list comprehension here, our comprehension. So we're going to say we want the point at the first index. So again, the x coordinate for all of our sample points in our sample data here. So we're going to say x0 for x in centroid dot points. So that'll be all of our x coordinates. Then we're going to do the same for the y coordinates, and we're going to say y1 for y in centroid dot points. So again, we're just breaking up those. That array of arrays of sample data into their x and y coordinates here, into arrays of their x and y coordinates. And then we're going to go ahead here and try to move them. So we're going to say centroid dot pos 0. So the x coordinate of the centroid should be the sum of the x coordinates of all the points that are assigned to that centroid divided by the length of those x coordinates there, and then centroid.pos at 1, so the y coordinate is going to be the sum of the y coordinates divided by the length of the y coordinates. Okay, and if we have an exception, then we're just going to pass. Okay. So now we've got that, we can update all our centroids, and now we want to go ahead here and just put a final piece, which is going to be if reset. Then we want to go ahead and set our centroid points to nothing. So this is basically, again, for plotting. So if we reset, then we want to go ahead and we know there's going to be a another iteration here, so we want to reset our points so as we don't just stack up a big array of all the previous points plus all the new ones that are assigned. So this will just keep that clean for us so we can check when the algorithm will end here. So let's go ahead and now we'll try another function, and this is going to be the actual fit function. So now we've defined the function that will establish the distance between any point and a centroid. We've established the function that will update the location of that centroid based on all of the points assigned to it. We have a function to generate sample data. So you can imagine here we're going to generate that sample data. We're going to run each point through this through that other function to find its closest centroid, assign that point to that centroid, then update all the centroids based on their assigned points, check to see if there are any changes between the previous points and the new points, and if there aren't, then we're going to cancel the algorithm and that'll be complete, and if there are, then we're going to keep running it through and keep updating our centroids, keep updating our groups. Okay, so now we're going to go ahead here and say we're going to define our fit function. Alright, so let's go ahead and get started on that. So again, here we're just going to fit, again, our points that are in self.x, and we're going to assign the points to the centroid and then update centroid location based on assigned points. Okay, so let's get started with this here. Alright, so what we are going to start with here is a variable that is going to represent the number of iterations that we've completed, just to keep track of how many iterations we're going through before all the points have been assigned. So we're going to say self.numIters equals 0, and then we're going to say fit equals false. And this is just what we're going to, a flag that we're going to use to decide when the algorithm has come to an end here. So now we're going to say, while not fit, we want to go ahead and say for each data point in our self.x, then we want to go ahead and determine the closest centroid. So we're going to say closest equals self.assign centroid point, calling that function that we created above to establish the closest centroid, which is then going to be represented by this closest variable here. And then we're going to say closest dot points dot append point. So then we're going to assign that point to its closest centroid. Okay, so now we can go ahead here and we can go ahead and check to see if the algorithm has, so it's assigning every point to the centroids. So now we want to check, are any of those points the exact same as they were before? And if they are exact same as they were before for each centroid, we know our algorithm is over. So let's create a little if statement to check for that. So we're going to say if the length of C for C in self.centroids if C.points equals C.previous points. So this is a little list comprehension here, guys, and what we're doing with this is we're saying let's create a list of all of the centroids that have the points that their current points equal their previous points. So that is going to be a list of that, and we're going to say if that list is equal to our number of centroids total, so we say so if that list is equal to self.n centroids, then we know our algorithm is over. So we're going to say fit equals true, and then we're going to say self. Let's see here, update centroids reset equals false. So now we know that's our final iteration here. We're going to go ahead and update our centroids one final time, and then we are going to leave those current points as their current points rather than reset it, so then we can visualize what is going on. Okay, so now we've got that here. Next up here, now if else, so if the algorithm is not finished here, then we just want to go ahead and call self.update centroids, and that will just do everything as normal. And otherwise at the end here, or not otherwise, but at the end, then we just update the number of iterations to be plus equals 1. Okay, so there we go. We've got our fit function, and now finally what we have to do here is create our visualization here. So we're going to go ahead and do that. Whoa. There we go. Okay, so now we're going to go ahead and do that. So let's go ahead and create our function called show. So we're going to say, let's just make sure we're in line here. We'll put it right at the top, right in here. So we're going to say def show and self. Alright, now for this function here, this is how we're actually going to visualize the final clusters. So we're going to go ahead and utilize that color property that we created for each centroid, and then we're going to go ahead and plot all the points and plot all the centroids themselves. So now we're going to say, we're just going to put a little comment, so we're going to say displays clustering. So let's go ahead here and say for I, C, and enumerate self.centroid. So again, we're using that index here and the centroid itself, and that's what enumerate does, is return the index as well as the actual object that is in the array. And then we're going to say plt.scatter C pause 0. So this is scattering the coordinates of the centroids. So right now we're plotting the centroids onto our scatter plot here. So we've got C.pause 1. And our marker, so this is just what the centroid is going to look like, is an O, and then we have our color is of course going to be the color of that was assigned each respective centroid, and then the S equals 75 is going to be the size of the centroid itself. Now we're going to go ahead here and say X coordinates, and now we're going to separate the X coordinates again using that list comprehension. We've got X, X0 for X in C.points, and Y coordinates equals Y1 for Y in C.points again. So we have our Y coordinates here. And I'm sure there's a cleaner way to do this, guys. I haven't looked it up yet, but I bet you I'm going to check out after this video. And this right here, I'm sure there's a cleaner way to do this with some inbuilt function in Python, so we're going to check that out after, and I'll probably leave that in the description if I find something. So next up here, we're going to say plt.scatter. So we want to scatter those points here. So we're going to say x coordinates, y coordinates, and marker is going to be the period, and then we have c color equals c.color. Okay, so now this is going through, and now for each centroid here, we are plotting the centroids points with a little larger size, though we're going ahead and we're breaking up the x and y coordinates into their respective arrays, which is how the scatter plot, or how plt.scatter function is going to work to plot those. And then we go ahead and we're scattering those with the same color as the centroid, so then each of its points will have the same color, and then the centroid itself will be a little larger, and we have slightly different markers, so we can differentiate those as well. So now we have title of the plot. So we're going to say title equals k-means, and we'll assign this in a little bit here. So title equals k-means, and then we're going to say plt.xlabel is going to equal, or no, it's just a function here. So plt.xlabel is going to be x, plt.ylabel is going to be y. And then we have plt.title, is we're just going to call on the title variable we defined above. We can just put down there, make it a little cleaner. And now we're going to go ahead here and say plt.savefig. And this will actually save the plot to a in a folder in this current directory for us, so that we can go ahead and view that later. Yep, that looks good. And now we're going to go ahead here and say plt.show to show our final visualization here. So we're going to see if everything checks out here. Chances are there's a few errors that we're going to have to fix up, but we're going to go down here and say km.simpledata. So we're going to say, to that we're just going to call km.fit and then km.show. Now let's see what happens here. Okay, so k-means object has no attribute update centroids in line 98. So let's see what we have there. Self.update centroids. Let's see, do I define that differently? Okay, I put this little, so I put a little underscore between our after this right here in order to show that this is a private function for this class. It's not usually called from outside of the class. So we're going to go ahead and put that in there. And let's see what we get now. Okay, centroids is not defined. So let's see, equals centroids.points in line 69. So we'll check that out. Okay, so centroid.previous points equals centroid.points. Let's fix that. Try again here. Okay, so there we go, but it looks like those colors are a little bit off here. Let's see what's going on with that. Everything else looked pretty good, though, as far as how the algorithm clusters and everything, but we got to fix up those colors here. Let's see what's going on here. Let's see. So when we're displaying our clustering, for some reason, so let's go down to our show function here, and let's see. So we're scattering those markers with the color itself. It's odd that our color is off. Let's see if we can figure this out here. Take a look. So this should be an equals here. Okay, there we go. That was a problem. So there we go, guys. Now we have all our clusters here, And we have all their respective points that they are, all the points that are assigned to the clusters. So again, our algorithm took in unlabeled data. It was able to build groups out of that unlabeled data, and then we can now use those groups to put into any other algorithm we want to. This can also be used to confirm business assumptions, a bunch of different things here, given that we haven't defined the groups ahead of time. I have a little list here of cool use cases for this, so I just wanted to share that with you guys as well. So detect activity types in different motion sensors, separating social media activity bots versus a real user, segmenting users by purchase history, a bunch of different cool business applications, and as you can imagine, those can be all fed into other applications as well for some very cool stuff. So again, thank you guys very much for watching. I hope you enjoyed this video. Be sure to like and subscribe if you did. We've got plenty more machine learning coming up here, implementing a lot of algorithms from scratch. And again, yeah, thank you guys for watching. Have a great day.